Hello and welcome back to unemployment. Today is day 14, and day 14 is going to be a bloody quick one because it's so hot everywhere. It's 8 p.m. and it's just like 50 degrees minimum. Anyway, today was pretty productive. I've learnt about many complex things because I want to move my command line expense thing that I've shown briefly to a HTTP thing that can have like a form that you fill out instead of a command line thing because I think it'll look cooler and I want to learn how to do that. So I'm getting there. And it's like with yesterday's video, it's the same thing with this website. Learn Go with tests. I was finally learning some of the complex stuff. So I started with uh, concurrency. So concurrency works by having channels that can do multiple things in concurrency. So in parallel, multiple things at the same time. Um, and yeah, it works by having channels which you have a go routine of a function. Sorry. Um, yeah, a go routine of a function that just works, but then you need to have a channel for it to know when to stop or start or something. I haven't actually done any proper writing with it yet, just because I've actually not got an excuse. I was literally just learning everything today. Probably should have learned it and then, um, wrote some code in it. But I was just thinking, like, I don't know. I couldn't think in the moment what I would use it for. What I'd use channels and go routines and stuff for. Like, what I could just make to test it about. Because the test that this was using, I was just thinking about that. In this example, in one of these examples, they were using a stack for something, and I just kept thinking, oh, that's the only thing that this is useful for. You know what I mean? Anyway, um, yeah. So basically, you need channels to work with Go routines and with concurrency, which makes sense. Um, yeah. So that's that really. I do understand it, but I'm gonna have to do some. I'm gonna have to do some actual writing of it, writing of code, obviously, so I fully understand it. And then I learned about selection, which is concurrently running tests, concurrently running channels that, concurrently running channels functions, like concurrently running something and then checking to see which one comes first. Really, it's like a race, I think. Let me check how this is written. Did I get it right? Where is it? Synchronized processes, yeah. Yeah, so I think I'm right. So, what was I saying? Yeah, select allows you to do multiple channels and wait on them and stuff, and it tells you which one will happen first, which is cool. So we have reflection, which is super confusing to me. And I don't really think I'm going to go into it, but it just says here, reflection in computing is the ability of a program to understand its own structure. So basically, in one of these examples, you have a function that doesn't actually tell you the exact type, and the code has to like infer it, and you've got to check all the types using this interface, this curly bracket thing. So I'm not really going to go into that because I really don't think I'm ever going to use it. Like at the bottom of it, it says it might be useful like sometimes, but let me scroll down. But it says like now you know about reflection, do your best to avoid using it. Trust me, I bloody will. And then we have sync. So exactly, sync is, oh yeah, sync is when you create a wait group. So it's a group of things doing something, I think. And then you have to lock and unlock them. So it's like if I wanted to do a counter, this is an example. They do a counter and then uh, they count in sync, however many times you want to count till. But then the number has to wait before it increments the next time. You know what I mean? So it's like they all happen at once, but they've kind of got to. I don't really know. It seems pretty useful, but I haven't really found a use case for it. So yeah, you need to lock it and unlock it to actually use it. Context, did I know about this? I think I did. Oh yeah, it's about testing long-running processes apparently. Where does it actually use provides functions to derive the new context from existing ones? This works from a tree when context is cancelled. All contents. Oh right, so in these examples, it tests to see if something gets cancelled and then it does it. But I really don't think I'm going to need that. Like I was getting a bit confused here, but then we actually get into the really interesting, which is generic. So I didn't really know anything about generics. I've just seen some pretty vague examples about it, and I couldn't really get my head around it. But now I get it. So a generic allows you to um, have like not have an exact type of a function or of a something, but have type safety, which is different to reflection or different to having no type because it's unsafe. So a generic works by like if I wanted to have a function that creates a list, creates a new list of type. So it could be any type. So it could be a list of int strings, blah 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 blah. You can create a generic that creates that list. Also, my hay fever is going mental, so I might pass away. Um, so you can have a generic that creates the list of type whatever that you supply, and then in that type, it will only work with its own type. You know what I mean? So if I have a list of ints, or maybe not a list, it's probably a bad example, but whatever. Um, let's just say a list that can only be of one type. Then if I have a list of ints, I try and add a string, it won't work, which is how a generic works, something like that. So it's just, yeah, it just works, or whatever. Does it tell you exactly what generics are here? So I can read it out just to get it working in my brain. Yeah, describe our constraints, but have flexibility and type safety. Yeah, I find it really interesting, and I think I could find some things to use it for, but I couldn't think on the spot because in this example they use a stack where you create a stack of strings or ints using generics. So yeah. Anyway, that's going to be it because it's so flipping warm. Um, see you tomorrow. I need to make some more stuff. Hopefully, make that HTTP thing because I learned a lot today.